Here's some law of sines and cosine word problems that you guys can work out. This is really good practice for the quiz tomorrow. So when you look at a problem like this, especially if it's been drawn out for you, it means it's relatively complicated. So one of the things you can do is kind of look at the problem and maybe redraw it so that it's a little bit simpler. So I'm going to kind of look at the picture. I'm going to draw the pieces that I feel that are really helpful. Okay. I know this is 75. We know that the tower is 100 feet tall. We also know that this angle at the bottom here is 6 degrees. And so we have, this is horizontal and this is horizontal. So this is a 90-degree angle because the tower has to be straight up. So we can assume that that's 90. If I've got a little extra, we know that alternating interior angles, so here and here would be the same number, so that's 6. This is going to be 6 as well. So 90 plus the little 6 extra angle here makes this bottom piece 96 degrees. Okay, and the question is, how long are these guy wires that hold up the tower, right? So I need to know how long this one is and this one as well. So we're really set up to find x here. The other side, if we kind of draw that at the same time, here I've got an angle that's going to be less than 90. So this is 75 still. This is still 100. If you look at the picture, that horizontal line still extends out like this. And so if you look at that, you've got vertical angles. This little tiny angle here, the 6-degree angle. And on the other side, if I were to just kind of extend that dotted line like this, that's going to be also 6 degrees. So that means I'm 6 degrees less than 90, right? And so this would be 84 degrees. We'll call this y. At this point, it's really left up for us to decide which trig function, law of sines or cosines, are we going to use to solve it. Since we have side angle side, right? Side angle side based on the triangles, I'm going to use the law of sines, or law of cosines, excuse me. So x squared equals 75 squared plus 100 squared minus 2 times the same two numbers, 75 times 100 times the cosine of the angle in between them. Same thing for the bottom one. It's going to be the side I'm looking for squared is equal to the two sides added together squared minus 2 times the same two sides. All right, this is kind of how I memorize this step, but just repeating this procedure each time I do the problem, and it makes a lot more sense the more I do it. Or it helps me to remember. And cosine of 84. At that point, I'm just going to plug it in my calculator. So when we solve for x squared, or x, excuse me, we're going to get 131.1 feet. Be careful. Don't forget to square root your answer. You're going to end up with a really large number, 17,000 and some change. So that's one of the steps people always tend to forget to do. So if it's really big, make sure to look at your other sides, make sure it makes sense in context. When we find y, find it to be 118.6 feet. Now, in the context of the problem, we know that y, this piece on the other side, should be much smaller than our x piece because of the way that the angle of the hill works. And it is, and so that makes sense. Always make sense of your problems. Here we have an awning design, and I have a lot of triangles to kind of mess around with. One thing we have to be aware of are the given information, right? So we know that we're given this side. That's the only distance. So I'm going to have to create a triangle using that, right? So if I kind of isolate the pieces that I know this, I need to know this piece. So that kind of leads us to use the triangle right here. We also know that the building and the ground make a 90-degree angle, so this makes this 20 degrees. So that really does kind of help us out. We also know the top part, well, this is going to end up being 40 degrees because of the right angle at the top. So we have 40 and 50 equals 90. At this point, we can find out the top angle. I'm going to redraw this out here. All right, so it looks like this. We know that this one is 40, this is 20. So we say 180 minus 60, this makes this one 120. And this is going to be 7. I'm looking for x here. So since we have a matching set of sides and angles, This one's going to be using the law of sines. So we're going to set 7 over sine of 120 is equal to x over sine of 20. And I'm just going to use the law of sines to solve this one. Multiply both sides by sine of 20, and you're going to end up with x equal to 2.77 feet. Be careful, don't let all of the extra kind of numbers inside here and the values to kind of throw me off. We did use the 70, we did use the 50, and the 7. So everything they gave us, we did end up using. There's a lot of different ways you can have done this in a little bit longer way. The first time I did it, I did it a little bit differently, but as long as you get to the right answer, it really doesn't matter if you take the long way or the short way. This one is probably one of the more tricky ones. You have to kind of do a few things here that that aren't written. So what we know here is that we have, if you draw a line vertically due north, we have an angle of 28 degrees here. We have an angle, vertical angle from the due north. We also have a 16.5 degree angle. We also know that this full angle from due north all the way to line of sight to tower B is 65 degrees. So the fact that we know this and this allows me to get this angle here. What I'm really trying to find is the distance to the fire from tower A and tower B. So in order for me to do that, I have a side length here, but in order to use the law of sines, I'm going to have to get this angle at the top. I can't use the law of cosines because I don't have this side, nor do I have this side. When I'm using the law of cosines, one of the things, if you haven't noticed, is that I have to have at least two sides. In this case, I only have one side, and there's no way for me to get the other two sides quickly. So let's draw in a few things and kind of take it from there. So if I extend these lines out, what you end up with, we know that lines that are due north, these are going to be parallel lines. And so I can kind of extend this. I can create this pattern at the top, right? You've got a right angle here and a right angle there. We know that if this angle is 28, we can get this angle by subtracting from 90. That makes this one 62. If we look at the other side, we can do the same thing to get this angle using the 16.5 angle measure. That makes this angle right here 73.5. Now, we have three angles, angle 1, angle 2, and angle 3 here, right? So 1, 2, 3, that add up to give me a straight angle, which is 180 degrees. So I'm going to add those two, 73.5 and 62. I'm going to subtract from 180 to get the angle 2 in the middle. So we end up going 180 minus, it's going to be 135 when you add those other two angles together, which gives us 44.5. That angle here in the middle is the one we needed. So this is going to be 44.5 degrees, which is exactly what we needed to have in order to solve the triangle. So I'm going to redraw the triangle out without all the distractions. That's really, really useful. So now this one is 44.5. We have I've got to figure this angle out at the bottom. So we're going to say 65 minus 28. It's going to give us 37. So we have 37 degrees here. We know that this is 30. I'm really trying to find A and B. So at that point, I can use all signs. So we're going to say, looking for a side length here, so we're going to say 30 over the sine of 44.5 equals A over the sine of 37. So A is equal to 25 point, we'll run that up to a tenth, 25.8 kilometers. In order to solve the other piece here, we're going to have to find angle B, which leaves us at 98.5 degrees. So we'll set up law of sines again. We're going to say B over sine of 98.5 equals 30 over sine of 44.5. And then gives us b is equal to 44.3 kilometers. In this case, that makes sense. B should have been larger. We have a 98-degree angle for angle B and an angle 37 degrees for angle A, which makes sense with it when you look at the size ratios of each one. This one is similar to one we've done in the past. This one's actually not nearly as complicated. What I'm going to do is I'm going to find out if this angle is 42. We're going to find out what this angle is up top, and then I'm going to subtract this angle from 42, kind of doing this right here, and to get what my theta is. So we're going to draw the triangle, not the right triangle, but the smaller one, like this. Oops, that's not right. Looks like this. So we have a 48-degree top. We have something in the bottom. Let's not call that theta. Let's call it x. All right. So we have B, C, A. We know that this is 10, and this one is 17. So here again, it's the law of sine. So 17 over sine of 48 is equal to 10 over the sine of x. If I can get x, I can say 42 minus x to get us this theta down here. So we're going to go ahead and find x. Don't forget to do sine inverse before you finish. So you're going to get sine x equals 0.4371. So that leaves us as x equal to 25.9 degrees. So to find my theta, we're going to say that 42 minus x is going to equal to theta, which makes theta, the little tiny angle at the bottom, which we were looking for, 16.1 degrees. The last question is about a regular octagon inscribed inside of a circle. What that means is the word regular here is telling you that each of these segments are exactly the same length. Okay? The fact that it's inscribed in a circle with a radius of 9 tells me that each of these segments going from the center out to the vertex is all exactly 9 units long. So if I extract out that triangle they drew, it looks like this. We have side, we need an angle, and we have side. So if it asks me about area, right, that's what we're asking to find, the area of this octagon, which means I have 8 triangles that are exactly the same. And so what I could do is I can find the area of one of them, and then I can find the area by multiplying by 8 to get the area of the whole thing. So we know that a circle all the way around has 360 degrees. We know that each of these little bitty angles are exactly the same. There's 8 of them. So if I can find the angle measure, then I can simply plug it into the formula. And so depending on the sides, if it's an octagon, a hexagon, it could be a nonagon or dodecagon with 12 sides, I'm just going to divide by that number, 360 divided by the number of sides. That's going to give me that central angle located here at the center of the circle, this little tiny angle right there, right, which is this one. So once I have this, we end up with side angle side, which is exactly what this area formula needs. So we plug it in, 1/2 times 9 times 9 times the sine of that one angle, 45 degrees. And that gives me 28.64 is the area of just the single triangle that we have here. But there's 8 of them. So I'm going to multiply that area by 8, right, to get 229.1. If there had been 12 triangles, I would have multiplied this response by 12, which would have made the angle here a little bit smaller, and so forth, right? So you can take any sort of polygon inside of a circle that's regular And you can always find that area by simply adjusting this formula by getting the right angle measure and using the radius of the circle here. And that's how you do it.